in the digital world. The system here is completely digital, no analog. And that worries a lot of people, that it's only digital. Have you experienced the same thing as me? That people are describing when a musical presentation is not really good, it tends to be described as digital. It's digital. And when it's very good, it's being described as it's analog. It's very analog sounding. Yeah, have you heard that? Yeah. And so we have been thinking about this, and when we encountered switches, people were talking about switch. The switch actually plays a role here. It plays an important role, according to some. And then 5 years ago, there were these audiophile switches popping up. So we started to think, we're cable manufacturers. So why would we get into the electronics world here?
Because you make LAN cable, right?
Yeah, exactly. Yeah. There is a good connection. We're going into, and every time when we talk about cables, we're basically talking about passive devices designed not to change anything, because theoretically they're passive and cannot do anything. Luckily, that was changed 30, 40 years ago when cable started to become a noticeable thing, that you actually talk about cables to improve sound, and you need to have good cables. So luckily that is behind us. But what about the switch? If you think about the switch, it's not a router, it's a switch. It's a layer 2 in the layer 2 category, supposedly very unintelligent, doesn't do anything, yet it makes a big difference. That's almost like a cable, isn't it? It's unintelligent, doesn't do anything. That's our expertise. We think of ourselves to be very good with understanding noise, where it comes from, and how to prevent it from interfering with the musical signal. And that's when we started to look into what an audiophile switch is, the people that are claiming to have audiophile switches. The first thing that we noticed was they're all made the same way. Off-the-shelf circuitry board with one of two things. Either a power supply built in or a clock put on a separate circuitry board. Or both. Those are the things that defines an audiophile switch. So we started to look at that, and very soon we realized one of the things that off-the-shelf solution cannot do, the distance between the connectors. RJ45 connectors are really bad, especially if it is more of a standard product. There is a reason why our top-of-the-line Valhalla has this heavy-duty, very screen-shielded connector. Those connectors are spreading noise all over. And if you buy an off-the-shelf solution, you will have these connectors side by side, very, very close as they can possibly get. They will spread noise between each other, inevitably so. There is nothing you can change because they are so close to each other. So we very soon realized that we need to put the connectors apart from each other. And we need to create a large distance. And if you do that on a line, it's actually going to be quite a wide product if you have adequate distance between the connectors. And also the thing we want to achieve is to have identical circuits from each connector to the main IC, the small little brain that there actually is in the switch. So the form factor of the QNET is not a coincidence. This is to save space, and we can have a large distance between the connectors and keep it a small form factor. So we actually have a very long distance between the connectors here, even though we have a rather small product. The other thing that we realized now we need to build our own circuitry board. It's not an off-the-shelf product. There is no circuitry boards that are around and fulfill our purpose. So we started from scratch, building our own circuitry board. And of course, when doing that, we pick the best circuitry board. We're audiophiles. So we got a 6-layer circuitry board where we can separate signal from ground, from communications, and so on. The other thing that we also understood is that even the cheap switches you see here, the really, whatever it is, $20, $30, $50, metal chassis. A metal chassis is very effective to screen incoming noise. So we went overboard. We have 2 aluminum billets. So this actually is made out of 2 very heavy aluminum billets where everything is CNC machined out. So you got positions for everything inside, and they're being put together with a special technology, no screws. So the form factor here, the result here is almost too good to me, because the satin black anodized surface, it's very smooth to the touch, and the craftsmanship doesn't really show on this product. It's almost too good.
Yeah.
Inside, we're using, remember power supply. We have, at the last show that I was 2019, we had the Q point and the Q source. Yeah. We already have an AC linear power supply that is very, very good. So we don't want to reinvent the wheel, and we also wanted to keep the form factor here. So that's our linear power supply. But linear power supplies are much quieter. They produce very little noise. So we have actually gone into using linear power supply internally in the DC domain. So DC linear power supplies are being used inside. That means that this product generates a bit of heat. It's not getting nowhere near as warm as the Mephistos. It's just getting nicely warm to the touch. So you cannot fry eggs or anything on this. Just be comfortable warm. The one thing to remember here is that we do produce some heat. So we have ventilations here and here. So do not place it upside down. It will block the ventilation. And if you put it to the right side, do not have anything covering this. That will also prevent the ventilation. Nothing is going to happen really, but it's unnecessarily stressing the unit. All right, so we have a lot of things built into this switch. But you remember what I said before? When we design a product, in order for it to become a product, it needs to be demonstrably better. And that's what we're going to do soon. We're actually going to make a bit of a comparison here. And the comparison obviously needs to be between our audiophile switch and the crappy whatever standard switch.
Yeah.
That is, remember, we are in the audiophile business. This is an audiophile switch. It has been designed with audiophile thinking. The things that inspires us are not what inspires the computer industry. Computer industry, they're talking about cost efficiency and speed. Those are the two factors in the computer industry. Audiophile, accuracy, precision, quiet, no noise. And in terms of speed, in our industry, when we talk about high resolution, it's not even close to what they talk about in the computer world. Even the biggest you can think of, the highest resolution we can think of, 8 times DSD, is probably around 12 megabit. So it's not even close. We don't use a fraction of the speed and bandwidth accessible. So remember that the speed has no relevance in our industry. We're even by 100 meg, it's far beyond what we're using. So that's the thing. We'll play a piece of music, and I am using, for this, I'm using internet streaming, Cobus. So just to emphasize that how much we can improve, well, that's for you to decide how much it improves, but to give you an idea of how much of a bottleneck a standard switch can be. So that's the comparison. The rig or the setup is, we got this standard switch here connected with a switch mode power supply.
The original one.
Yeah. The QNET comes with, in the box, it comes with a switch mode power supply, so you can work with it to begin with. So now it's powered with that. So the comparison will be only the switch functionality, not the power supply. And then I'll make another comparison where we actually connect the QNET to the Q source. Yeah. All right? Let's do it. This is a live recording on purpose, because live recordings, it's a good live recording, and there is a lot of things happening in this. There are certain sounds that moves in certain ways and so on. So let's see if you appreciate this. We probably need to be at 48 or something.
Volevo stare un po' da solo per pensare tu lo sai.
All right. So just a very quick switch, pun intended. Yeah. Again, listen to that intro.
Volevo stare un po' da solo per pensare tu lo sai.
Yeah. So, did you notice that when you lower the background noise, the three-dimensionality, the effects, the surrounding effects of what is going on is severely improved? Do you agree? Yeah. Yeah, thank you, because that is what has inspired us. When you lower the noise floor, that's when you start to realize how much you have missed, how much that was hidden in noise. and how much of a bottleneck the switch actually can become. So, and also, of course, the typical parameters, Andrea Bocelli's voice is so much warmer and intense and present. There are so much more feelings. And the female voice, same thing. Those are what you would expect. I like the beginning there because it really gives you an impression of how much you have lost. And going back to what I said in the beginning, you remember that we typically define if it's not so good, it's digital, and if it's really good, it's analog. To me, this second version is much more analog. It's smoother, more feelings, intense, and have that three-dimensionality.